Okay, I hope you're sitting down and I hope you have a snack or something with you because this I know is not like where on earth would you start, right? So this is kind of throwing two topics in together. The one is the equations, which we've obviously you can see this is an equation, but the other one is indices. And I have a whole series on indices, so you should watch that video to understand. But whenever you have an equation like this and it's kind of written in this way and there's an index and the index has the unknown valuable value in there, the kind of giveaway always is this ground number is I'm going to have to write this big number. They'll always give a big number. It might be 46, it might be 216, it might be 81. It's going to be a big number, but that number will either be a cube number or a square number or something, but it will be able to be rewritten. So when I look at this, I look at this 3 and I'm asking myself immediately, the first question I'm asking, is it possible for me to write 27 as 3 to the power of something? So 3 times 3 I know is 9. So 3 times 3 is, so 3 squared I know is 9. Let's just do that. 3 squared is 9. 3 to the power of 3 is 27. Bingo. So in this, I actually have to go that route and I have to rewrite this number. There's no other way of solving this unless I use logs, and that is year 11. Well, it's not, I don't even know if it's in year 11 syllabus, but we're not going to go the log route. So easiest way is just rewrite this as 3 to the power of x, and then write 27 as 3 to the power of what you know is 3. And now I see, wow, these numbers are the same. So that would mean that this number should be the same. So I just rewrite this now as a new equation saying 3x has to be 3. And then x I divide by 3 on both sides, right? And x would be 1. So it's a bit tricky, and the only tricky bit is knowing that this big number, you'll have to rewrite it as an index or in an index form. Okay, let's take a look at another example. Hopefully that wasn't too stressful for you. You're still here and awake. Let's say 2, and we say 4x plus 1, that looks so intense, is equal to 8. Yes, I mean, I would get such a big fright if I see that. I have no idea what that is. Yeah, that's going to be tricky. So because they're giving this in an index form, I know 8 should be rewritten in the same kind of form. So I know 8 is the same as 2 to the power of 3. And I know I have to think about 2 because there's a 2 there. So it has to be 2. The 4x plus 1 is written to 2 to the power of something. And in this case, I know, luckily for me, so they won't give a 9 or a 7, right? Because 9 or 7 can't be written with 2 as our ground number. So, no, sorry, that's 4. There we go. And now I see, the ground numbers are the same, so I can write this part and this part as an equation on their own. So 4x plus 1 is equal to 3. And now I just manipulate this like we've always done. I subtract 1 on both sides, so I get 4x is 2. And then I divide by 4 on both sides, and then I would get 2 over 4, which is the same as a half. And we can just test it. So if I have this, 4 times a half is 2, plus 1 is 3, and 2 to the power 3 is 8. Okay, so the trick, like I said, is just rewriting this. Usually with any indices type of questions, the trick would always be to write the big numbers they give you as in terms of like in index form, okay, as a power or a ground number to a certain power. Okay, let's do the last one. This one is going to, this is tricky. This is even worse. Oh my goodness. Oh dear, you have to know your indices really well for this. If you don't know your indices, then please watch the indices video because this is going to get really extreme really quickly. Okay, so we have powers to powers and stuff, and I know this is a 2 and I know that's a 4, and the idea of this is to get the numbers kind of the same. Okay, I want the ground numbers the same. I know I can write 4 as 2 to the power of 2. Okay, so that I know. So I'm going to sub that. Let me just write the 4. Let me write this. So I'm going to write 2 to the power of 2, because that's 4, right? And this is all to the power of 3x. Okay, and that's kind of, I mean, I didn't change anything. If I put this in brackets, 4 to the power of 3x is the same as 2 to the power of 2 to the power of 3x. It's like a power tower. It goes up in powers. And this would be this part just stays the same. And now the index rule that you need to know is if I have a to the power of 2 to the power of 3, it becomes a 2 times 3, which would be a to the power of 6. So in this case, I have to multiply these two, and I would have 2, and then 2 times 3x is 6x, is 2 to the power of x plus 1. And now I see, finally, I got my ground number is the same, so I can write this as an equation on its own as 6x must be x plus 1. I bring this over, subtract x on both sides, and I have 5x is equal to 1, but I don't want 5x, I want x, so I divide by 5 on both sides, and x is then a fifth. Okay, that is it for these videos. If there are other equation videos that you want to know how to solve them, I'll do them later. I'm not going to do quadratics right now, but we can do that in a different series.